Okay, welcome to this recording. And on this recording, I wanted to go through few highlights on the content of this week's chapter relating to nutrition especially. And I think that during this video, we'll get through all of these points that I've included here. Unfortunately, enough often we don't have enough time to spend on the class discussing the nutrition, which is an important aspect as kind of a continuity of our digestive system. So at least want to make sure that we cover them at this point. So, a couple of things to get us thinking and started with the content for this section. The term metabolism refers to all chemical reactions in the body. And in this context, it obviously would be the most foods that are used as a metabolic fuel. And these foods are then oxidized and transformed into adenosine triphosphate, so ATP. And as you might remember, ATP is our cellular energy currency. So this is really the chemical energy that drives cellular activities. And there's really two metabolic processes that I want us to be comfortable and familiar with. Let's start with catabolism. Catabolism refers to breaking down larger molecules into smaller ones. And as we're doing this, as we're breaking these larger molecules into smaller molecules, we end up releasing energy that has been stored in these bonds between these particles. And this is really what happens when we digest food. We break larger food molecules into smaller, and in the process, we're able to release that energy that can be then made into ATP and utilized to drive our body processes. The opposite reaction of this that we can see would be anabolism. In anabolism, we combine smaller particles to form larger molecules. This process to combine these smaller particles actually takes or consumes energy. And this is how we would, for example, make new tissues as part of growing or repairing tissues in our body. Okay, next thing that I wanted to talk about relates to the fact that our body relies on nutrients as a source of materials for many functions like growth, maintenance, and repair. Let's look at major food groups, and there's really going to be 5 that I want to highlight for us at this context. I wanted to talk about the fruits. Some examples could be, for example, apples, bananas, dates, oranges, or tomatoes. So major nutrients that we find in the fruits include carbohydrates and water. Some of these also contain vitamins such as A, C, and folic acid, also minerals like iron and potassium, and fiber. Then we have our vegetables. Some examples that I can think from the top of my head would be broccoli, cabbage, green beans, lettuce, potatoes. And major nutrients that we find in all of these would be our carbohydrates and water. Some of these also include vitamins such as A, C, E, K, and B, as well as minerals like calcium, magnesium, iodine, manganese, phosphorus, and fiber. Then we have our grain products. Grain products, with these, I think it's worthwhile to think that preferably we would like to have whole grain. Otherwise, we prefer enriched or fortified sources like breads, rolls, bagels, dry and cooked cereals, pasta, rice, and other grains, tortillas, pancakes, waffles, crackers, popcorn, things like that. Major nutrients in these grain products that we find in all of these are carbohydrates, protein, and vitamins. And some of the vitamins could be, for example, thiamine, B1, and niacin. In some of these grain products, we also see water, fiber, and minerals. And the minerals would be, for example, iron, magnesium, or selenium. In terms of the milk products, and some examples of milk products, of course, would be milk, yogurt, cheese, ice cream, iced milk, frozen yogurt, things like that. These milk products, the major nutrients that are supplied in all of these include protein, fat, vitamins, riboflavin, B12, minerals, for example, calcium and phosphorus, and water. In some, we also see carbohydrates and vitamins such as A and D. And final group that we see is going to be meats and meat alternatives. Examples would be, for example, meat, fish, poultry, eggs, seeds, nuts, nut butter, soybeans, tofu, and other legumes such as peas and beans. Major nutrients that we find in meats include proteins and vitamins like niacin B6 and minerals like iron and zinc. Also in some meats, we'll see carbohydrates, fats, and vitamins such as B12, thiamine, B1, water, and fiber. I think the really big take-home message about these food groups is that diet consisting of foods from these 5 food groups normally guarantees an adequate amount of all of these needed nutrients. So moving along, there are many different recommendation systems about how one should eat. Some of the most commonly used ones are highlighted here. So first we have our healthy eating pyramid, which was issued in 1992 and contains 6 major food groups arranged horizontally based on how much they should represent of your caloric intake. And then we have a little more recent My Plate model that was issued in 2011 by the USDA. This contains 5 food groups that are arranged on a round plate to show again how much of calories should be taken in from each of these. Now, let's look at major nutrients, and we have seen this top line already. So let's look through each of these groups. Carbohydrates, as a first one, dietary carbohydrates are sugars and starches. Most of these are derived from plants, such as fruits and vegetables, and there are exceptions such as lactose from the milk and small amounts of glycogens also from the meats. Then we have our lipids, saturated fats from animal products, especially meats, and unsaturated fats from things like nuts, seeds, and vegetable oils. We also see cholesterol from egg yolk, meats, and milk products, so our dairy products. And the final group that I wanted to introduce is going to be our proteins. We have complete proteins that contain all essential amino acids. Most are from animal products like eggs, milk, meat, poultry, and fish. And then we have essential amino acids that really don't, your body cannot make and must be obtained through the diet. Legumes, beans, and beans also have proteins, but these proteins are incomplete. So really what I wanted to highlight from here is that, interestingly, this is the order in which these are utilized for the energy in your body. We first utilize carbs, therefore these no carb or low carb diets are used when we try to get rid of lipids, so fats. And then if we don't have those carbs, like I said, we move on to fats, so burning off the body's adipose tissue steps in here. Finally, if we don't have carbs, we don't have lipids, proteins can serve as a source. And because proteins are not stored in the body, they need to be available in your digestive system when you need them. So we see, for example, bodybuilders at the gym consuming protein drinks or protein powder when they train to bulk up the muscle mass. And you remember muscle was made of protein, so they want to ensure that there's this availability of a protein when needed for this purpose. Otherwise, if you don't have carbs, you don't have lipids, and you still train and you don't get proteins from your diet either, you can end up consuming your own structural proteins, so your own existing muscle as a source of energy. So that's something to keep in mind if you're trying to bulk up. You want to have those sources to build those muscles. Now let's have a look of micronutrients, and these are found in smaller amounts, but they are still important. These would include, for example, vitamins. These are complex organic compounds, and there's really two types. There's fat-soluble ones. These are vitamins that dissolve in fats and are influenced by the same factors that affect lipid absorption, including, for example, vitamin A, which plays an important role in, for example, in visual pigments, skin, hair, mucous membranes, bones, teeth, and epithelia. Vitamin D, some important roles, for example, in teeth, bone, calcium, phosphorus, heart, nervous system, are vitamin E, playing role in cell membranes, protecting blood cells, tissues, fatty acids. Vitamin K, important role especially in blood clotting. And then we have vitamins that dissolve in water. So these are known as water-soluble ones. And these are many forms of vitamin Bs and also vitamin C. So what's important is to see that these fat-soluble vitamins will stick around in your body, whereas these water-soluble vitamins you need to constantly get because they don't get stored in your body. And in addition to vitamins, we're also going to see minerals. These are mainly important for enzyme activity. Some foods that are richest in minerals include vegetables, legumes, milk, and some meats as well. Now, let's look at energy balance in the body. When the body is said to be in homeostasis, so in equilibrium or balance, we have the same amount of energy going in as we have energy going out. And this energy is released from the body during digestion, and energy is lost largely as heat. So about 60% is lost as heat. Any excess energy gets stored as fat or glycogen. And we can have too little or nutrients, or we can have too much nutrients. And both of these lead us to deviate from this state of homeostasis. Now, it's not just how much we eat, but also what kind of food we eat. And different nutrients yield different amounts of energy. And some of the measures that I wanted to introduce as we wrap up would be our basal metabolic rate, so our BMR. This is how much energy is used just to keep essential body processes going. So essentially when you're laying in bed at rest. And this differs from one person to another. Average BMR is about 60 to 72 kilocalories per hour on an average sized adult. And remember though that many factors will affect your BMR, such as your body size, your sex, your age. We see that older you get, slower metabolic rate you have, and so on and so on. I've also mentioned there our total metabolic rate, so TMR. This is really the total amount of energy needed to fuel the ongoing activities at that moment. So for example, if a lot of muscle activity is taking place, then we obviously need more energy to fuel those. And we also see BMI. This is our body mass index. This is a mathematical calculation that quantifies the amount of tissue mass of an individual and compares it to then others. There is some criticism towards BMI as it's simply a mathematical formula and not as much of based on scientific evidence of one's health. So as an example, think of wrestlers that have a lot of muscle mass. Based on the BMI, we would often classify them as grossly obese. And obviously this is not the case when we try to look at how healthy they are. So BMI doesn't equate necessarily to one's healthiness level. And that really brings us to the end of everything that I wanted to highlight when it comes to the key points of the nutrition and our chapter on nutrition. As always, I appreciate you being part of this class, and I very much look forward to continuing working with you in our online spaces. Until next time, thank you and bye.